Welcome to Teachers Andy's class. It's lesson 10, our final lesson. It's about tips and tricks of word problems. So you've learned so many tricks and tips. Now let's conclude all of them. Here we go. So there was a basket of bananas. Emma took 5 more than half of all the bananas. And Ben put 6 into the basket. And Lily finally took 3 less than half of all the bananas. Currently, there were 15 left in the basket. How many bananas are there in the basket at first? Okay, so how do you solve this problem? We can actually use the method of working backwards. Okay? However, you do need to understand the meaning of more than half of all the bananas and 3 less than half. Okay, so 5 more than half. That means first take half. So divided by 2 and then 5 more means you need to minus 5. So that's the meaning of 5 more than half. What about the meaning of 3 less than half? So less than half, again, divided by 2 and then 3 less than half. That means you actually need to put 3 back into the basket. So plus 3. That's the meaning of 3 less than half. So here comes our summary. So more than half divided by 2, then subtracted by the additional number. So 5 more than half, so divided by 2, and then subtracted by the number of 5. And then, what is the meaning of less than half? First divided by 2, then added to the diminishing number. Okay, 3 less than half divided by 2, and then add 3, right? You put 3 back into the basket. Okay, so this is the first question. And this is the meaning of more than half and less than half. Okay, next. There are some stars in a line given the pattern. So there is a pattern, right? And what color is a 32nd star? And what is the sum of blue stars in the first 32 terms? So you need to find the specific color and you need to find the summation, okay? The sum of the blue stars in the first 32 terms. How do you solve this? Again, there is a pattern, so you need to find the pattern. So red, red, yellow, blue, blue. Red, 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 yellow, blue, blue. Red, red, yellow, blue, blue. So you notice that actually the pattern repeats itself for every 5 stars, right? So we can actually use a box to represent a pattern. So we can use 32 and divide 5. Let's say 32, here we go. 32 divided by 5 equals 6 with a remainder of 2. So that means, what is the 32nd star? It repeats 6 times. And then with a remainder 2, that means this is the first one, this is the second one. So the color will be red. So this is how you solve the problem. And you can actually use the same way to calculate the sum of blue stars, okay? So here comes this pattern. So we can find the pattern of stars, okay? This is the method. And every stars in the every box, every 5 stars in every box. So you have 2 red, 1 yellow, and 2 blue. And then we can put 5 stars into a box. So 5 stars into a box, and you know that there are 6 boxes with remainder of 2. So this is a simple division. The number of boxes, that's 6, and extra stars out of boxes, that's the remainder. And this is how you solve this kind of problem. Okay? All right. So here comes question number 3. There you go. So Dad bought 80 pieces of candy. Lots of candy. Who doesn't love candies? So Emma picked 30 of them and left the rest to Ben, okay, and Lily. The number of candy got by Ben is 10 more than the number of candy got by Lily. So how many pieces of candy did each of them get? Okay, so how do you do this? So you first notice that this is the whole number of candy is 80. And then Emma picked 30 of them. So how many left there? So there are 50 left to Ben and Lily. And then you need to understand the meaning of more than, okay? So the number of candy got by Ben is 10 more than the number of candy got by Lily. So we can actually use a model. We call it a comparison model, okay? We can draw a comparison model, and we can actually use 1 unit to represent Lily's candy, because Ben got more and Lily got less. And then we know that Ben is 10 more than the number of candy got by Lily. So 1 unit plus 10, that will be Ben's candy. Okay, so you can say it here. When you try to solve this kind of problem, you first draw a comparison model to solve this kind of problem. So Lily got 1 unit and Ben 10 more than what the candies Lily got. So 1 unit plus 10, and the whole candies got by Lily and Ben is 50. So you have this mathematical expression, and then you can get the value for 1 unit, and then you know exactly how many candies Lily got and Ben got. So this is how you solve the problem. Okay, next. Emma and Ben have 43 cupcakes. First candy and then cupcakes. This is so cool. So altogether, there are 43 cupcakes. Emma has more than 3 times as many cupcakes as Ben. How many cupcakes does each of them have? So, how do you solve this kind of problem? First, you need to understand the meaning of 3 more than 3 times. Okay, first, 3 more than 3 times. 3 times means 1 times 3, right? 1 unit and times 3, 3 units. 3 more than 3 times, so 3 units plus 3. So when we try to solve this kind of problem, we actually still draw a comparison model, and we use 1 unit to represent Ben's cupcakes, because Ben got less and got more. So Emma's cupcake will be 3 units plus 3. And then you know how to get the value of 1 unit. And then you know each of them, the candy, the number of candies, okay? So here we go. So you know the meaning of 3. First, you need to know the meaning of 3 more than 3 times. So you can actually make a table, and here's 1, and then 3 more than 3 times. So 1 times 3 is 3, and 3 plus 3 is 6. And then how about if Ben got 2 cupcakes? So first, times 3, 2 times 3, 6, and 6 plus 3, that's 9. And then what about 3 cupcakes Ben got? So 3 times 3, 3 more than 3 times, right? 3 times 3 is 9. 9 plus 3 is 12. So we have 12 cupcakes. So this is how you understand the meaning of 3 more than 3 times. We can actually simply make a table and try to deduce the meaning of 3 more than 3 times, okay? And then we have this. So the total number, this is our comparison model. You know the total number, and you know Ben has 1 unit of cupcakes, and Emma has 3 units plus 3. That's 3 more than 3 times. So you have this mathematical expression, and then you have the value of 1 unit, and then you know the cupcakes Ben got and Emma got. So draw a comparison model to solve the question. And now you know how to do this, right? And then we have this one. Emma and Ben were fighting monsters. Okay? Together, okay? Emma fought more than 4 times as many monsters as Ben. If Emma fought with 19 more monsters than Ben, how many monsters did each of them fight? It's pretty similar with the previous one, right? So first you need to understand the meaning of 4 more than 4 times. If you have a hard time with it, you can actually draw to make a table, and then use 1 monster first, and then 2 and 3, and then you understand the meaning of 4 more than 4 times, right? And then another one is next we will draw a comparison model, so we can use 1 unit to represent the monsters Ben fought, because Emma fought more monsters. And then we know that the monsters Emma fought will be 4 units plus 4. That's the meaning of 4 more than 4 times, right? And then you know the difference between them is 19, right? Emma fought with 19 more monsters than Ben. So use the monsters Emma fought minus the monsters Ben fought is 19. So we can actually use the comparison model and to express it in mathematical equation, and then we get the value of 1 unit. And then you know how many monsters did each of them fight, okay? So first, draw a comparison model to solve the question, and then you know the mathematical expression, and you get the value of 1 unit, and then you know the monsters fought by Ben and Emma, okay? All right, next, the final question, the classical rabbit and chicken problem, okay? So a farmer raises chickens and rabbits on his farm. The total number of animals on his farm is 16. The animals on his farm have 36 legs in total. How many chickens and rabbits does the farmer have? How do you solve this problem? We actually use assumption to solve it. So we can first assume that all the animals are chickens. Why? Because each chicken has 2 legs, each rabbit has 4 legs. So each chicken has less legs than each rabbit. Okay? So let's say 16 animals are all chickens. This is our assumption. And times 2 is 32. Okay? Whoops. 32. And we notice that in total there are actually 36 legs. So 4 legs are missing. Oops. Why 4 legs are missing? Because we actually turned the potential rabbits into chickens, right? So each time when 1 rabbit becomes 1 chicken, 2 legs are missing. So 4 legs are missing. 4 divided by 2, that's 2. That means we have 2 rabbits, and the rest of the animals will be chickens. So 2 rabbits and then 14 chickens. So that's how we find our answer, okay? So next time when you try to solve this kind of problem, we can first use assumption, right? We assume that all the animals are chicken, and then we get the number of the legs, and then we can actually notice that 2 legs will be disappeared if we actually assume that each rabbit will be 1 chicken. And then we know 4 legs are disappeared, right? So 4 divided by 2, 2 rabbits, and the rest of the animals are chickens. And this is how we solve the classical chicken and rabbit problem. Okay, every time when you try to solve this kind of problem, we actually have our method, right? First, you need to understand the question. You need to find the very useful information. And you need to understand what kind of answer you need to solve, right? You need to find. And then you use a method or maybe use a model and to solve the problem. At the end, you need to check your solution. For the chicken and the rabbit problem, we actually can do the final check. And for each problems, you can actually do the final check. So 2 rabbits and 14 chickens. So 2 times 4 plus 14 times 2, we will have 36 legs. That means we are correct. So always do that. So this concludes the tips and tricks of word problems. And this concludes our lesson 10. I hope you really have learned a lot. And I can't wait to see you next time, okay? For next series of course. Take care. Bye.